Hello everyone. For this tutorial video, I'd like to explain the root test, which also uses absolute convergence. We define the root test as the limit L as n approaches infinity of nth root of the absolute value of a subscript n, which can be rewritten as a subscript n absolute value raised to the power of 1 over n as n approaches infinity. We next see, with some careful reasoning, that similar to the ratio test, if the limit is less than 1, the series will converge to a finite value. If the limit is greater than 1, the series will diverge, and if the limit is exactly equal to 1, we do not have a definite answer. So we will do one series with the root test to see how this works. If we have this infinite series, we would see we can use the root test by taking the absolute value of this, raising the absolute value to 1 over n, then taking the limit as n approaches infinity. We see the n in the numerator cancels out. By similar reasoning, the 1 divides by n, and the 2n has the n's cancel out. We see as n approaches infinity, the numerator approaches infinity, and the denominator approaches 3 to the power of 0 plus 2, which is 3 squared equals 9. But the 9 is not relevant, because the numerator is infinite. So we know, because it is positive infinity, it is greater than any positive integer, including 1. In conclusion, the series diverges. Now that we have figured out all the possible methods of testing whether infinite series converge or diverge, we can discuss very special and specific types of infinite series, starting with power series in the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.